Okay, take a moment, please, and read through example number 3. Well, let me try to draw in a rectangle. I have no clue where exactly this is going to land, so let me just kind of draw it in like this. And I've got my rectangle. And I know that my rectangle is going to intersect the parabola at the point x, comma, y. I want to maximize the area. What's my primary equation going to be? Well, let me think. If this point is x, comma, y, I know that the height of this thing is y. I know that this is x, which means the entire base has got to be 2x. So my area is 2xy. I now need to get a secondary equation, some way to relate the x's and the y's. Any clue where that might come from? Any clue where that might come from? Oh, what do you know? We have a way to relate the x's and the y's. That formula is going to be my secondary equation. I'm going to go and I'm going to plug that in for y. I'm going to get a equals 2x times 20 minus x squared, or a equals 40x minus 2x cubed. Next, as for a domain, x, well, is this point, but it's also like a length of half that side. I know it's got to be greater than or equal to 0. I also know that x can't be greater than whatever this point is over here, the x-intercept of my parabola. Well, we can find the x-intercept of the parabola by taking the formula for our parabola, setting it equal to 0. We'll get x squared equals 20. X equals square root of 20, because I know it's got to be something positive. I'm thinking 2 root 5. And the point is, I have a closed interval here, so I can use the candidate's test. Please take a moment, find your critical value, or values, of that area formula, and submit those to Edpuzzle. Okay, so my derivative is 40 minus 6x squared. I'm just going to set this equal to 0, and I'm going to say 6x squared equals 40. X squared equals 40 over 6, or 20 over 3. X equals, I don't care about the negative square root, I'm just going to say square root of 20 thirds. And you know what? Let's just leave it. That'll be good enough. I'm going to set up my candidate's test. X and a of x. I need 0. I need square root of 20 thirds. Actually, rather than 2 root 5 for the other one, let me just call it root 20. It's going to make things a little bit easier. Actually, I'm just going to cheat. I know that's 0. I know that's 0. For the other one, I've got 40 times the square root of 20 thirds minus 2 times the square root of 20 thirds cubed. Oh, you know what? It would be easier if I plugged in over here. So let's plug in over there. We're going to use some whiteout. Oh, wonderful. Let's plug into the factored version, because then I can square a square root and not have to bother with the messiness. I'm going to get 2 root 20 thirds times 20 minus, I know root 20 thirds squared is just 20 thirds. Let's see here. This is 60 thirds minus 20 thirds. That's 40 thirds times 2. We're going to get 80 thirds root 20 thirds. And I know I could simplify, but I kind of don't care, so I'm just gonna leave it like this. And I know I'm going to get a maximum over there. What are my dimensions? Well, The base of my rectangle is 2x. I know that x is root 20 thirds, so the base is going to be 2 root 20 thirds. No units because we're just on the coordinate plane. The y, we need to go plug root 20 thirds into our formula for y. What do you get when you plug in root 20 thirds? Well, let's see. 20 minus root 20 thirds squared. That's just 20 thirds. This is 60 thirds minus 20 thirds. I think that's 40 thirds. These are the dimensions. I'm fairly certain in the homework the numbers are a little bit nicer than this.